about static friction. Our purpose is to determine and compare the coefficient of static friction of different materials. Let's go!
Before we start the experiment, we are going to need one wooden ram, one styrofoam, one piece of paper, one piece of sandpaper, one flannel, two wooden blocks, and one plastic ram.
And here are the steps.
Step 1. Put your block into one of the ramps you've prepared and then put the ramp on a table. Step 2. Then slide the ramp till the block slides off. Step 3. The ramp will form an angle between itself and the table, forming an imaginary triangle. Measure the angle, the adjacent, and the opposite sides of the imaginary triangle. Step 4. If you want to change the base of the block, cut the material you want to use into the shape of the base of the block, and then stick it onto the base. Step 5. Repeat steps 1, 2, 3 2 times per block per ramp. For instance, do the steps 3 times to a wooden block on a wooden ramp, and then do it 3 more times on a plastic ramp.
To start all off, we are going to place a wooden block onto a wooden ramp. Now, measure the angle between the ramp and the table. The angle present is 19 degrees. After recording the angle, measure the length. In the video, we have 50 centimeters. Once you have that, measure the height. Here we could see that the height is 15.5 centimeters high. As we said before, we are going to do the experiment 3 times for every block in order to minimize the mistakes. After doing the experiment for 3 times, we have compiled the data into the following table. Here, the coefficient of static friction results to 0.34. Now, we are going to do the same thing with a different ramp. This time, the ramp is made out of plastic. Once the ramp is tilted, measure its length, height, Now, we did this experiment for 3 times, and these are the results. The coefficient of static friction results to 0.39 with an inclination of 21.31 degrees. It is now time to change the surface of the block. We are going to stick different materials on the bases of the block. Keep in mind that we are using the same block because changing the block could cause different results. We have 4 bases that we are going to try out. But the first one off is the flannel cloth. After sticking the flannel cloth onto the bottom of the block, after completing the experiment with different surfaces, the result has come to our hand.
From the experiment, we can derive the formula to determine the coefficient of static friction. Look at this free body diagram. The angle at which the block starts to slip on the ramp is directly related to the coefficient. When the two objects are horizontal, there is no frictional force. As the objects are slowly tilted, the force of static friction must increase from 0 to counteract the component of the force of gravity that acts along the interface. Eventually, as the angle increases, that component of the force of gravity exceeds the maximum value of the force of static friction, and the block slides off. But how does this angle at which this occurs relate to the coefficient of static friction? Here we can use Fs equals to Fs max equals to mu Sn, because this is the angle at which the force of static friction equals its maximum value. Split the force of gravity into x and y components, with x down the slope and y perpendicular to the slope. Apply Newton's second law twice. Substitute the second expression to the first. The factors of mg cancel. Rearranging gives. So the coefficient of static friction is equal to the tangent of the angle at which the block slides off the ramp.
After collecting all the data, the combination of materials that has the highest and lowest coefficient of frictions are sandpaper and wood with a coefficient of 0.97, while the lowest is block of wood and wood with a coefficient of 0.34.